Okay, so here are some examples of problems with calculating probabilities for sample means. But in the same process, we're going to look at old problems, which are Chapter 3 problems that we've previously looked at, versus new problems, which are sample mean. So if I highlight real quick, this is an old problem right here because it says a single measurement. However, this one right here is a new problem because it talks about a sample mean. And so we'll refer to old versus new as we go through some of these examples. Okay, so we are not going to look at A or B right now, but we are going to go ahead and look at the directions that says, suppose we randomly select a sample of 64 measurements from a population having a mean equal to 20, standard deviation equal to 4. We're going to do C. Can you find the probability that a single measurement will be greater than 21? So I'm going to use up here for a little bit. Probability that X will be greater than 21. So this is an old problem. What we're going to do first is we're going to calculate our Z-score. Okay, if we were to look at a distribution here for this, our mean would be 20, and we're at 21, so we're a little bit above the mean, and we want to be greater than that, so we're here to the right. So X minus mu divide by sigma. 21 minus 20 is equal to 1. 1 divided by 4 is 0.25. So now we basically want the probability that Z is greater than 0.25. This is an area to the right problem. You can either look up the 0.25 and subtract from 1, or you can look up negative 0.25. If I look up negative 0.25, I get a probability of 0.4013. Now, that is the answer for this C. Now if we go ahead and we look at the new type of problem, calculate the probability that we'll obtain a sample mean greater than 21, we would write this out, and I'm going to use this space right here for this new one. Probability that X bar is greater than 21. Now here's how things will be different. We're going to calculate our Z like we did before. X minus mu divide by sigma. But instead of sigma this time, because we have a sample of 64 measurements, we have to do our sigma divide by the square root of 64. So 21 minus 20 is 1. 4 over the square root of 64 that's an 8, so it's going to be 4 over 8, or 1/2. This is going to be equal to a 2. So now we want the probability that Z is greater than 2. So again, we're going to either look up 2 and subtract from 1, or look up negative 2. If I look negative 2 on my chart, I get 0.0228, and that would be our answer for this one. So let's look at some more examples. Let's look at hospital length here. Okay. The average length of a hospital stay is 9 days. I will just highlight that. Mean. Standard deviation of 3. Assume a simple random sample of 100 patients. Let's go ahead and just kind of break down the problem. I'm not going to look at these first two. I'm just going to go right to the bottom. What is the probability to obtain a sample mean less than 9.6 days? Again, because the word sample mean was used, this is the new type of problem. The new type of problem has this, x minus mu sigma over the square root of n. And remember, n is your sample size. So we want the probability that the sample mean is less than 9.6. So we're going to go ahead and calculate our Z again. Z equals 9.6 minus our mu, which is 9, divide my sigma, which is 3. So that is 0.6 divide by 3, which is equal to 0.2. So now we are looking up, what is the, but we have to have 3, divide by the, where's my pen? Divide by, let's do a new color, the square root of our n, which is 100. So that's the new part of the problem. So we really have 0.6 divided by 3 divided by 10 is 0.3, and 0.6 divided by 0.3 is equal to 2. So we are really looking at what is the probability that z is less than 2. We're going to go right to our chart. This is an area to the left, so we're just going to go ahead and look it up. 2 is 0.9772. Let's go ahead and look at this example. So, if we look at the important information for this one, we have a normal distribution with a mean of 18.6, standard deviation of 5.9. What is the probability that a single student randomly chosen scores 21 or higher? What type of problem is this? Because it is a single student, this is an old problem. So this is where we would just go z equals x minus mu divided by sigma. Okay, I'm not going to actually do that one out. Now let's go ahead and go down to this example right here that says what is the probability that a mean score of these students is 21 or higher. So because the mean is asked for, we've got a sample of 50 students from this part of the information here. This is a new problem. So we're going to go ahead and calculate it as such. What is the probability that the mean score is greater than 21? So we're going to calculate our z. Z equals x minus mu sigma over square root of n. X is 21 minus our sigma, or mean, 18.6, our mu. Sigma is 5.9, divide by square root of n. N this time is 50. So we got to do the square root of the 50. So 21 minus 18.6 is 2.4. 5.9 divided by the square root of 50 is ugly, so I'm just going to write it like this. And so we're going to do that calculation all at once. And when we do that calculation all at once, we are not going to round till the very end. So when I do that calculation, 2.4 divide by, and then put parentheses around it if you're doing it all at once on your calculator, 5.9 divided by the square root of n, you should get 2.876, yada, yada, yada. Okay, the rounding is extremely important here. Z-scores go to 2 decimal places. So we are going to round this to 2.88. Again, the rounding is extremely important here. Because it is area to the right, we're going to look it up and subtract from 1, or you can look up the negative 2.88. If I look up negative 2.88, I get 0.0020. And that would be our answer. Let's look at one more. Let's go ahead and, I'm going to blow this up real quick. I'm going to look at the auto accidents example. The number of accidents at an intersection, mean is 2.2. Standard deviation is normally distributed. Okay. What is the approximate probability that x bar is less than? I'm just going to go ahead and say that this is an old problem. Some of these, I'm not really a big fan of some of them, the rest of them, so we're going to stop our recording right here.